Hi folks, we're going to do the fourth one of the related angles. This is in EdX and it's called vertical angles. They're sometimes called opposite angles as well. So here it is. Let's take a look.
Suppose you have two intersecting lines. This angle over here happens to measure exactly 50 degrees. Notice that this angle over here is supplementary to the 50-degree angle because together they make a straight 180-degree angle. So what's the measure of this supplementary angle? If you're not sure, click over here to review.
Remember, supplementary has two P's in it, and that's how I remember it. Two P's is two perpendiculars or 180 degrees. Complements are 90. This is 180, of course. So if you're talking about supplements, now we want to get the rest of this angle. So what do you have to add to 50 to make 180? 130, of course.
Exactly. This angle is 180 degrees minus 50 degrees, or 130 degrees. Next, take a look at this angle down here. It's supplementary to the 130-degree angle because together they also form a straight 180-degree angle. So what's the measure of this angle?
Remember, 130 is supplementary with 50, and also 50 is supplementary with 130. So since these two angles are supplements, that has to be 50.
Right, just like the first angle, this angle also measures 50 degrees. And finally, this angle down here is supplementary to this 50-degree angle as well as to this 50-degree angle. So what's the measure of this angle down here?
And of course, 50 and 130 makes 180.
Nicely done. So this angle also measures 130 degrees. So we have two pairs of congruent angles here, meaning angles that have the same measure. On opposite sides of this intersection, we have a pair of 130-degree angles, and we also have a pair of 50-degree angles. Angles on opposite sides of intersecting lines are called vertical angles. They're called vertical angles not because they run up and down, but because they have the same vertex or corner at the intersection. And as you've shown in this example, vertical angles are always congruent to each other, meaning they always have the same measure. So take a look at this pair of intersecting lines. Of the four angles here, select two that are a pair of vertical angles.
Okay, clearly this one and this one are vertical angles. They're across from each other and they share the same vertices.
Right. These two angles are vertical angles. They're on opposite sides of the intersection and they have the same measure. And which two angles represent the other pair of vertical angles? Now in this interactive, you can rotate these two lines by dragging them around. One pair of vertical angles is colored yellow and the other pair is colored blue. Try moving these lines around to make sure that vertical angles are always congruent. Then try answering this question. If both pairs of vertical angles have the same measure, meaning all four angles at this intersection are congruent to each other, then what is that measure?
Hopefully you guys will try this little deal here and try moving them around and seeing that they're the same. He wants them to be the same, so it looks to me like those are all the same angle, and we are supposed to put the value in here. And if they're all the same, this angle plus this angle plus this angle plus this angle, they're all the same. That's x plus x plus x plus x makes 360. Another way to think of it is that if these are both equal to each other, and they're all equal, then these two is 180 and they have to be equal. Anyway, lots of ways to go. And to get your answer, which is 90 degrees.
Okay, so let's try another problem. Suppose you have three lines that all intersect at a single point. this angle has a measure of 72 degrees, while this angle has a measure of 65 degrees. So try using what you know about vertical angles to find the measure of this angle over here. If you get stuck, just click over here and we'll figure it out together.
Okay, so write this down on your paper and try it out. This 72 could be moved to here because these are vertical angles. 72 would be down in this area. So 65 and 72 plus your new angle makes 180. And if we add them all up, you'll get it. Another way to look at it is that you can say, okay, we've got 72 here and 65 here. And all three of these angles add up to 180, don't they? Well, this angle and this angle is 138. And you need 42 more to make 180. So 42 degrees is this angle right here. Because this one, sorry, 43. 43 and 137 makes 180.
Excellent. There were a few different ways you could have solved this using supplementary and vertical angles, and this angle measures 43 degrees. This angle is also 43 degrees because these are a pair of vertical angles. Similarly, this angle measures 72 degrees, and this angle measures 65 degrees. So vertical angles, which are angles on opposite sides of two intersecting lines, are always congruent to each other, and you can use this fact to find the measures of unknown angles at intersections. Okay, here's your final challenge. Suppose you have two intersecting lines, and I tell you that this angle measures 2x plus 30, and this angle measures 7x minus 25. Try using this information to solve for the variable x, and click down here if you get stuck.
Okay, because we know that these are both equal measures, we know that 2x plus 30 is equal to 7x minus 25. And in order to solve this equation, you're going to subtract 2x from both sides. If you don't know how to do that or why we do that, go back and look at the ed puzzle that I gave you for review of basic algebra. We subtract 2x from both sides and we get 5x. We add the 25 to both sides because we have 5x minus 25. So we add the 25 to both sides and you get 5x equals 55. And when you divide by 5, you get your answer of 11. Now, I recommend that you write it out. It's going to be a lot easier, and then you'll have the answer.
Nicely done. You set these two expressions equal to each other and found that x equals 11. So finally, let's double check your answer. Try plugging in 11 for x in both of these expressions and make sure you get the same measure for both of these vertical angles.
This one is going to give us 22, because 11 times 2 is 22, plus 30 makes 52. This one is going to give us 77 minus 25, which is also 52, my favorite number. And they're both 52 degrees, of course. And we're done. That's it.